I'm going to give a bit of a introduction to Docker and Singularity containers, a bit of background on the difference between Docker and Singularity, and then sort of basic commands you need to know to run containers. So yeah, this is all up on GitHub again. Let me just grab the link and put it in Discord. Okay, let's make a start. So to give an overview of container engines like Docker and Singularity, we talked about this a bit before. So Docker and Singularity can be used to deploy software packages in a container, which is a lightweight, standalone, and reproducible environment. So we've mentioned before that container images tend to be lightweight. We tend to try and keep the size of them down, and they're sort of standalone from our host machine, providing that level of isolation which allows for a completely reproducible environment, unlike Conda, where we've discussed the different problems with different underlying build dependencies across platforms. Our container image that we sort of pull from Docker Hub or different container registries is always going to be the same. So it allows software to run uniformly regardless of infrastructure. So why should you be using containers? So we can think of containerization as a bit of a different approach to software development, where as our software is packaged with all its dependencies and everything it needs to run, it provides this useful level of virtualization. So, you know, you probably, if you encountered GitHub issues in the past, if you looked at sort of GitHub issues posted on yourself or problems you're having with software, it can be quite difficult to sort of debug problems across platforms of, you know, we've all seen the sort of issues of people saying, well, it works on my machine and it doesn't work on someone else's, things like that. By having that same environment in which to run your software, it makes life a hell of a lot easier when debugging problems with software that everyone's running in the same environment. It's also a way of isolating software packages from each other. So, you know, similarly to splitting up our Conda environments, we can split up our Docker Singularity images. So have different image for different software packages. And resources such as Biocontainers provide a wide range of container images for bioinformatics software. Which are just, you know, ready for you to use, easy to pull from Docker Hub or Key. And containers also integrate well with Nextflow and Snakemake to create these fully reproducible workflows where you can use containers for the software dependencies within your workflow. To allow for, you know, reproducible research. So just to talk a little bit about sort of useful definitions. So the workflow for creating a container, it all starts with a container recipe. So in Docker, these are called Docker files. In Singularity, it's usually referred to as a Singularity recipe or definition file. So it's just like a little script, basically, that provides instructions to Docker or Singularity on how to build the container image. We'll see a little bit in a later slide what these Docker files and Singularity recipes look like. So then your container image, which you've built from your Docker file or Singularity recipe, that's like acting as a snapshot of the container. That's what contains all the software and its dependencies. And then at runtime, then when you run a container, that's when the images become containers. So a few more useful definitions. So volume. We'll see this later. Volumes are what are used in Docker to access data on your host machine, your local machine. So this is essentially how we handle input and output from the container. So giving Docker access to the input files and then getting the output from the software run in the container onto our host machine. So we'll see what that looks like later. So volumes aren't used in Singularity. Singularity uses something else instead called a bind mount, where it mounts your home directory for you to allow you access to your files and to handle the input and output. Don't worry too much about this. We'll see what this actually looks like in the practical session after lunch. So container registries. So these are the cloud-based services that are used to distribute images. So you probably find that mostly you interact with Docker Hub. So this is the sort of main registry that Docker pulls from. Singularity can also pull from Docker Hub. And Singularity has a useful feature where it can convert a Docker image to a Singularity image. So what Singularity does when it pulls from Docker Hub is it takes that Docker image and it converts it to a Singularity image for you. There's also another registry called Key, which hosts Docker images. Probably increasingly seeing that used to host bioinformatics containers. So you can pull from Key as well. And there are also registries specifically for Singularity. So Scilabs is the main one. And there's also Singularity Hub, which I think has now been archived, so it's no longer being updated, but I think you should still be able to pull images that are previously uploaded from there. And when we use the term container engine, so this is what creates and runs the container. So for example, Docker engine. So to give an overview of Docker first. Docker works for all major Linux distributions. Can also run on Windows and Mac for an application called Docker Desktop. And Docker manages images, containers, and volumes through a daemon, and there's a command line interface that then communicates with this daemon. So we'll see a little bit what that looks like later and how you interact with this daemon to manage your images and containers. So Docker does require sudo access to run. You need to run as root. So because of that, there are a few little oddities of that in terms of when you get your output from your Docker container, files will be owned by root, which can lead to some behavior maybe that you wouldn't expect, but I'll show you what that looks like later in the practical session. And because of that as well, you're very unlikely to find Docker on a traditional HPC system, because obviously on a traditional HPC cluster, they don't want to give you root access for obvious reasons. So you're probably much more likely to find Singularity, which doesn't require root access. So to give an overview of Singularity, so I think it was developed really to sort of overcome, sort of maybe, some of these sort of limitations with Docker, that it was developed with HV systems in mind, allowing more effective security than Docker on an HPC system. And so it's much easier to make use of GPUs and things like MPI with Singularity as well. It's much easier to communicate with them. And as well, it's bind mounts to your home directory. So it's probably a little bit easier for people to use because of that. You don't have to, with Docker, you're always having to think about how to mount your volumes. So for Singularity, your sort of home directory is just sort of there for you to use. So it's a little bit more straightforward. And it's a little bit different from Docker as well. You'll see later, we'll have a play of both of them. But instead we had these CIF container image files. So the sort of Singularity image is just this file that sat on your desktop. And I think these were sort of created with sort of easier distribution in mind, that it's quite easy to just distribute a Singularity image to someone, because it is just a file on your desktop. So yeah, some differences, some of which we've already mentioned. So Docker can only work with Docker images. So you can't use the Singularity image with Docker, but Singularity can convert a Docker image to a Singularity image for you. And this is a useful feature, because then we can pull from Docker Hub a Docker image, and Singularity will convert it to a Singularity image for you. So it does have that duality that Docker doesn't have. Previously mentioned, Singularity mounts the home directory for you. As Docker, you have to think about how you're providing the Docker container access to your data, and the different user permissions that Singularity you can run as your user, whereas Docker you're always root. So only Docker has support for Mac and Windows. So yeah, if you're sort of looking to run containers on your sort of personal computer, if it's Mac or Windows, I would look to just install Docker Desktop to use containers. So which should you be using? I mean, they're both valid choices. I would say Singularity does have some advantages over Docker, that I think it is a bit easier to use in terms of mounting the home directory for you, and the way it manages containers. With Docker, you're always sort of interacting with this Docker daemon, and sometimes having to do a bit of cleanup, which you don't have to do with Singularity. You're much more likely to find Singularity on your university HPC system. So in terms of Snakemake and Nextflow as well, so Nextflow provides support for both Docker and Singularity. Snakemake only provides support for Singularity, but remember, Singularity can use Docker images and convert them to Singularity images for you. So even though it is using Singularity, you still do have access to those Docker images. You can still pull those from Docker Hub, and it'll just convert it to a Singularity image for you. So I think in terms of, if you're interested in building and distributing your own images for other people to use, maybe for your own software, then building Docker images and sort of hosting them on Docker Hub or Key, it does provide more flexibility than building a Singularity image, because that Docker image you build, then people will be able to use it with either Docker or Singularity, because like I said, Singularity can pull that Docker image and convert it for you. So yeah, it's a little bit different. You're thinking about building images. I would build Docker images if you're looking to get the maximum sort of user base from them. So in terms of how we download Docker images, and also how do you find these images? You know, where do you look for them? So, and I think in particular, if you're looking for an image for bioinformatics software, I would go to Biocontainers. I think Lee's posted a link in the chat actually, so you can take a look at Biocontainers. So they maintain bioinformatics container images on both Docker Hub and on a registry called Key as well. And you can pull from either of those with Docker and with Singularity. As well, it's good to look at the GitHub page for the software package you're interested in containerizing, because they could well have a link to their officially maintained container image for you to use. And you can also search as well. You can search on Docker Hub through the reb, or there is this command line interface as well that you can use the Docker search term and search on the command line. And to pull an image from Docker Hub, it's quite straightforward. It's just a Docker pull command with the name of the repository and then the tag. So what the tag does is it links to different versions of the image. So with bioinformatics software, you'll see that the tag is usually different versions of the software. So basically this tag allows you to pull the different versions of the software. So obviously this goes back to reproducibility then, that if you sort of did an analysis of an old version of the software, you can still pull that older version of the container to sort of have a reproducible analysis, rather than pulling the latest version, which might not give you the exact same results. So downloading Singularity images. So Singularity can interact with a lot of different container registries. So it can interact with Docker Hub and Key, where it will pull the Docker images and convert them to Singularity images for you. It can also interact with Scilabs, which is the sort of main Singularity container registry. It can interact with Singularity Hub as well, but note that Singularity Hub is no longer being updated. It is archive only. So similarly to the Docker pull command, it's just a Singularity pull command with the repository and the tag again. But you see this little path at the front that's telling Singularity what registry you're looking to pull from. So it's library for Scilabs, and then it's Docker for Docker Hub. I'll show you later as well how to pull from the Key registry. So what sort of images are available? So you'll find a lot of bioinformatics software has existing container images. Again, Biocontainers is a good resource for this. And you can also find container images for programming languages. So you can find official images for Python and R. So this can be quite a good way of, if you've written a small Python program or script, you can sort of package it with the official Python container, or sort of use the Python container images to build on top to provide a container for your software. And there's also container images for the different Linux OSs. So you find images for Ubuntu, Debian, Alpine, and others. And Conda images also available. So these are what are used by Snakemake, for example, when you're sort of building a Conda environment within a container. You're building it within it's the official sort of conda container usually. So working with images and containers of Docker, we'll see how to do all this later in the tutorial after lunch. But here's an example of some of the commands of how you interact with the Docker daemon. So you list all your downloaded images with the Docker images command. So this is what it looks like when you attach a volume. So given the Docker container access to your input files on your host. So it's the V flag. Then you give the absolute path to the files, so the full path where your files are found, and then map it to a path in the container. And the Docker run command is used to run sort of custom commands. So you sort of give your image name and then the command you want to run. And there's also things you can do as well, like run an image with an interactive terminal. So you can sort of bash into the image and sort of run several commands. And it's quite useful actually if you're sort of building your own Docker images and something's gone wrong with the image. It's usually one of the easier ways to fix it is to bash into the image and see what's sort of gone wrong. We'll take a look at what this looks like later. And yeah, a few more commands of how to list all your containers and their status. Again, we'll see this later. And there is a little bit of cleanup involved with Docker in terms of removing exited containers. We can use the docker contain prune command to do that. So with Singularity, so it's a little bit different. So if there is a command called Singularity run, but what that command does is it runs the run script for container, so like a default command that's been set up for the Singularity container. If you want to run a custom command in Singularity, then it's the Singularity exec command, where you can then specify the command that you want to run in the container. So the thing you sort of got to remember really is when running a command in a container, in Docker, you're looking for the Docker run command. In Singularity, you're looking for Singularity exec. So that's just something to remember. Yeah, so working at volumes with Docker, again, don't worry about this too much. We'll see what it looks like later. This is how we attach a host volume to the directory in the container, and we always provide absolute paths with Docker. So this is what sort of Docker files and Singularity recipes or Singularity definition files look like. So these are the instructions that can be used to build container images. You may never interact with these if you're just looking to sort of download other people's images, pull them from Docker Hub. You don't need to worry too much about this, but if you're interested in building your own images, this is what the instructions to build an image looks like. So this is a Docker file on the left, and at the top we have a from command, which tells Docker the base image we want to build on top of. So we're building on top of a Debian base image. We then set environment variables. This is quite useful to set environment variables in a Docker file, because we can then set sort of the version so that every time we build from this Docker file, it will be built in the same version of the software. And it makes it a lot easier to update Docker files as well if you're just changing this number at the top rather than have to go through the run command and sort of replace lots of numbers. So this is the run command, telling Docker the commands to run to install your software. So if you ever installed software on the command line, you'll probably sort of recognize this using apps, then pulling software from GitHub and installing and so forth. And then this command at the bottom is just specifying a default command to use with Docker. So then Singularity recipe, you notice it's quite similar, where it's bootstrapping this Docker image and converting it to a Singularity image for you. Again, you can set environment variables, default run command, and then the commands then the instructions to install the software for Singularity. So if you are writing your own container recipes, there's a few things to bear in mind. So consider what you want to use as your base image. So on here, our base images, we're using Debian, but you can build on on top of sort of different base images. And there's sort of base images for Linux distributions such as Alpine that are very small. They can help keep your image size down, but they might not actually contain all the tools you need. So you might find you're having to install a lot of packages in your container to sort of get your software running. Use environment variables to set the software version, make updating a lot easier, make sure that you're installing the same version of the software if you do rebuild from your Docker file. And just a note that each Docker and Singularity command creates a layer, and so these layers can take up, increase the size of your image. So that's what this chaining is, this sort of slash ampersands, is to have, instead of having several run commands, is to run the one run command where it's all been chained together just to keep the size of your container image down. So just briefly, there's a useful tool called Singularity S-Python, which I use quite a lot. And it has a useful feature that allows you to convert between Docker files and Singularity recipes. So and you can install it using pip, or you can build a Singularity image for S-Python. And quite often what I do is I'll write a Docker file, and then I'll use S-Python to automatically convert that to a Singularity recipe, so I can maintain copies of both. So actually these recipes back here, I originally wrote this Docker file, and then this Singularity recipe on the right, that's just been automatically generated using S-Python. So if you are interested in maintaining both Docker files and Singularity recipes, you can just write run and then just use S-Python to translate it to the other. So Nextflow and Containers. So Nextflow can use both Docker and Singularity. It integrates very nicely with both. So there's no need for you as a user to mount volumes when using Docker with Nextflow. That you just specify the container image to use, and Nextflow does all the hard work for you. So we've talked a bit about this Snakemake, but you can define one container for the entire workflow, or define containers on a process level. Again, I suggest you define them on a process level rather than just having one large container. And Nextflow has the ability to build profiles for both Docker and Singularity and Conda as well. So you can provide for your workflow profiles for all three. So then it allows the user your workflow to select what profile they want to use and whether they want to run your workflow with Docker, Singularity, or Conda. And I think finally, that's also, we've discussed before, Snakemake uses Singularity. And again, I suggest you define containers at a rule level. And if you are getting started with container images, either pull them from bio containers, or look at using this ad hoc combination of Conda environments with the container, where Snakemake can build your Conda environment within the container image that you specify. So yeah, that's everything. Have you got any questions?